am the CEO of Trace Matters. $1 billion is poured down the drain every year by US refineries in what is known as margin leakage. What this means is that profits are being drained by running plants non-optimally. To give you an example, to illustrate, say diesel is the most profitable product in a refinery at the moment, and the refinery is maximizing gasoline. That's not optimal. Now, chemical composition is a key input in refinery optimization. You need chemical composition that is accurate, and you need it often for effective optimization. However, this is the status quo. There is no lab-grade analysis in real time available, which leads to offline optimization. That means optimization happens in stages. It's not continuous. That leads to margin leak. Now, to put it this way, it's planning production in a refinery is like trying to drive blindfolded. You cannot adjust for conditions that you cannot detect and measure. So, this is the ideal state. Lab-grade analysis in real time. That will lead to real-time optimization, which will lead to no margin leak. However, there is no instrument in the market that can provide this until now. My name is Al Galindo. I am the CEO of Trace Matters, and we will enable lab-grade analysis in real time. This is what production looks like in a refinery today. This gap between plan and actual results in lost profits. So, the longer that this gap remains and the wider that it becomes, the higher the margin leakage. I worked at the Port Arthur refinery for almost 3 years, the largest in the US. Its optimization manager of this state-of-the-art refinery is telling us that their margin leakage looks just like this. But why hasn't it been solved? Well, again, because there is no analyzer that can provide lab-grade and fast analysis. So, if we can provide a unit that can provide these two features in one unit, and we can provide a solution for refineries, then we can solve this gap. This is the gold standard in chemical analysis, mass spectrometry. It's lab-grade because of its high unmatched sensitivity, specificity, and it's able to detect liquids and gases. However, you can only find this in a laboratory because it's $500,000, it's the size of a fridge, and only an expert can operate it. So, refineries need to wait 3 to 5 days to get results back, which lengthens the gap. So, what they use most often, up to 40 times per shift, is a machine like this, field UV spectroscopy. Now, this is highly inaccurate, especially for heavier liquids. Diesel and heavier is up to 50% inaccurate, which leads to widening of the gap. But it's the only option that they have. So clearly, these two options are not adequate for the refinery user. So, at Trace Matters, to fulfill our mission to provide lab-grade analysis in real time, today we introduce the world's first mini-mass spectrometer that can be used in real time by the common user, fully automatic, push-button operation. Finally, chemical analysis in real time is within reach. This is our competitive landscape. As you can see, we will be the only solution that can provide lab-grade, portable unit, easy to use. So let's talk about our customers. Some customers require lab-grade analysis. Some require remotely and some in real time. We operate where lab-grade meets real-time and remote. Our initial market is the refinery optimization market. We chose this market because we have industry knowledge. We know what we need to do to get things done in this market. This is a valuable source of development feedback. There is no process change required on the end user side. They are aware of the problem and they know that chemical analysis can solve their problems. There is little education to be done. It's high growth market, and it also will give us high gross margins, which will fund our development. And we estimate this market to be $185 million. There's also a very large follow-on market. Serviceable addressable market, oil and gas, and petrochemical. $1.6 billion, and we'll start addressing this by year 5. Examples include production monitoring and advanced mud logging. Now there's also the total addressable market. we estimate it at 7.8 billion. We'll start addressing this by year 8. And examples include allergen detection in food and blood testing at point of care. There's another example. Just last week, Bill Gates warned the world to prep for bioterrorism. Now, in 2016, just last year, the Department of Defense issued this solicitation. They're saying that the existing solutions that they have in the field are not capable of detecting bio threats in the field. And while mass spectrometry works, they cannot take it to the site. So they're asking somebody to develop a unit that's a mini mass spectrometer like the one we're developing. So the core technology, it's the same for any of these markets. As we decide to approach new markets, we'll just have to build a new application around it to go for them. We'll go directly to our customers in our initial market. This is because we know them very well. There are few of them and they're large, so we can approach them. And we need a direct contact with them so we can get valuable development feedback. There's strong interest. We even have a letter of intent from Halliburton. They are saying that they need our product urgently because they take days or weeks to get the results back from the core analysis. So they want to lease our prototype as soon as it's ready. Same for Motiva and from SGS, the largest inspection company in the world. We have a working lab prototype. It was developed at the same laboratory at Rice, where the mini MRI was developed and is now a commercial success. We have our IP strategy will include trade secrets and patents to have access to Rice expertise. The same that attracted more than $20 million to this lab in funding from government and private entities. So this is our biggest competitive advantage. I am the CEO. I have 10 years of experience in the oil and gas downstream business. Felix Ortecho is our COO. He spent 12 years in the upstream business. He spent years on rigs all around the world, and then he became subject matter expert at Halliburton. Dr. Mazdak Tageskui, he is our CTO. He's a leading scientist in the field of mass spectrometry and an opinion leader. He is also an expert in patent prosecution, which gave us a huge advantage in our IP strategy. Dr. Aydin Babakani, he's our technical advisor. He's director of the Rice Integrated Systems and Circuits Lab, and he has led the development of numerous technologies through commercialization. Mr. Omar Kubranstad, he has 30 years of experience in oil and gas, and he led his company RigNet to IPO as his CEO. His key for success was knowing his customers, and we'll take the page from his playbook and many others. We are seeking $500,000 to complete our first briefcase prototype. We have the right team, we understand the industry, we know what we need to do to be successful and to get things done in it. We have world-class mentorship and guidance, proven science that we're working on, 2 years of a head start, and a working prototype to show for it. An existing attractive market and huge potential for a new market, and traction from a letter of intent. Thank you. And now, I'm happy to answer any questions.
Can you go back to your competition slide and talk a little bit about, it went by so fast I didn't quite catch what some of the competition was, and more importantly, kind of along with that is, why hasn't this been done before?
Right. There's a few factors. One of them is that technologies that are now available have enabled some of the development. For example, there's a very high vacuum that is required, and vacuum pumps were not available in mini form factor before. Same for electronics. Electronics they need to control down to the picoamp level, and that wasn't available before. Even today, it's not available in the market in some cases, but we are developing some of these components in-house. Yes, sir.
What stage of if 100 is you've got the prototype completed, what stage are you?
So we have our
80%, 60%?
Of the development towards the first field prototype.
Yes.
We are probably around 75%. We estimate around 6 months, 4 to 6 months to get to our first briefcase prototype. That's a stage in between. Our briefcase prototype will still need to be operated by ourselves, but it's going to be portable. Then after that, 6 months later, we'll have a field prototype that we can send to the field, and a user that's not our own scientist can use it.
Do we have any patent protection at all?
So we have our strategy includes IP, trade secrets, and we're working on establishing which components of those trade secrets will be patented, and we're working on that. We have our CTO is an expert in patent prosecution.
But you don't have any technology that's not available to anybody else.
We have developed it in-house, yes. So it is not available in the sense that nobody's working on this medium aspect as far as we know. It's not available in the market, and so we have a technology that's not available in the market, which is the lab prototype that we're showing. Does that satisfy your question?
Sure.
Yes.
How often does it need to be calibrated, and who are the operators of this?
So in its final form, as a production unit, we expect a 6-month maintenance interval. For example, our first user will be the refinery operator. So this unit will reside next to the sampling point, or maybe far away with tubing, and so he will be the user. It will be the operation will be transparent to him. So we will also act as a service company, and then we would maintain it, and we will make sure that it's functioning correctly.
So are you considering the rent or the lease?
Yes, that's correct. So we're planning to lease it.
Okay, not sell, okay.
No, sorry.
Probably last question, 45 seconds.
Yes, sir.
Yeah, the funding milestone says there's 450 units in your business plan in year 6. I mean, how many units total are there?
So that's the total. I put a note in there.
Now,
That's
how
cumulative.
many in the world? So what percentage of this is this of the world market?
Oh,
Because you're talking chemical processing, refineries, et cetera. So I mean, what's your addressable market in terms of number of units?
well, so it is not a straightforward question for this reason. So right now the solution is a very different type of model. So right now laboratories have their large machines that are general purpose, and then users will send samples to them. So now very few users have these machines. They are very expensive. Now this unit is going to be, the user will have this unit, and he will have many of them. So it is not apples to compare the quantities.
Well, thank y'all so much. We will bring you.